Finally, the last in our series of videos on how to solve systems, this time by elimination. I'm not going to go over in detail what elimination is. We're just going to think about what we did in the previous video about equivalent systems and equations and just use that in order to find a method to solve systems. So let's just start off with an example. I put two equations on here, and I'm going to use the fact that when I add together two equations, the third equation, when used with another one of those equations, will give you the same solution as the original two. And that's a mouthful, but you'll see what I mean as we do it. So the first thing I would always do is I'm just going to label these 1 and 2, and now I'm going to create equation 3 by a clever choice of addition or subtraction. So you can see here what I'm going to do is add. Adding's a little bit easier here. So if I have 3x and I add 4x to it, I get 7x. And when I add y plus minus y, I get nothing. So I'm just going to leave that off. I get 7x equals 21. Now, this equation is now equation 3. And equation 3, when taken together with either of the other two, will give you the same solution as the original equation. We saw that in the previous video. So I'm going to use equation 2, because it looks a little easier to me, but it's completely your choice. So 4x minus y equals 2, and the second equation I'm going to use is equation 3, which is 7x is equal to 21. Now I can use equation 3, 7x equals 21, to find the x value. Super easy because it just has one variable in it. So x is equal to 3. And now I'm going to use equation 2, so sub x equals 3 into equation 2 to solve for that missing y value. So I get 4 times 3 minus y equals 2. Now I just need to solve this. So 12 minus y equals 2. I'm going to subtract 12 from both sides. Minus y equals minus 10. So y is equal to 10. And the point of intersection then for any of the equations, and remember the question we were being asked was for 1 and 2, but it doesn't really matter because you get the same solution no matter which two of those three equations you use. So the point of intersection, 310. So that worked out really well, and hopefully you can see the reason why it worked out really well is because when you add those together, you eliminate the y value, and hence the name elimination. So let's take a look at one where that doesn't work out so well. Well, we're going to use our facts that we know about equivalent equations in order to help us get this one. So we're going to multiply both of these equations by something that will keep the equations exactly the same, as in they have the same graph, so the intersection point's not going to change. And when we do that, we're going to try to make it so that the equations are going to have the same coefficient for one of the variables. So in this case, I'm going to try to make them the same for the x values. So I'm going to multiply the top equation by 5 and the bottom equation by 4. So I'm going to end up with 20 x's plus 15 y's is going to be equal to 65. And on the bottom, I'm going to end up with 20 x's as well, which was our goal, so it's nice that that worked out. Minus 16 y's is going to be equal to minus 28. So now I'm just going to leave these equations over here, and I'm going to subtract the two. So minus 15 minus 16, well, maybe we'll do this first. 20x minus 20x is nothing, so I don't need to write that. And then I have 15y minus 16 is 15 plus 16 is 31. So 31y is equal to, and 65 minus 28 is 93. Minus gives you positive. Notice how I keep like cursoring over this minus. I'm trying to keep track of what I'm doing. I don't want to forget and do 65 minus 28. I'm subtracting both equations from each other, so I have to subtract the right-hand sides as well. So 65 minus 28 is 65 plus 28, which is 93. Now when I divide both sides by 31, y is just going to be equal to 3. And now, once again, this is like my third equation, so I can use that now. So I'm going to sub y equals 3 into any of the other two. Okay? So I should label this 1 and 2 now so I don't mess up which one I'm talking about here. And I'm just going to use 1 because those are all positives, and that's kind of nice. So 4x plus 3 times 3 is equal to 13. So 4x plus 9 is equal to 13. Subtract 9 from both sides. 4x is equal to 4. and x is equal to 1. And so then what do we get at the end here? So we get the point of intersection. So therefore, the point of intersection is equal to 1, 3. Okay, so that one's a little bit harder, but you can see how powerful elimination is. We don't have to go through all that mess that we did with substitution. Now, what if it's not as pretty? What if it's not laid out in a way that is as straightforward as the other ones were? So the first thing you want to do if you see something like this is get the x's to line up and the y's to line up. So I'm going to add 2 over 3x to both sides on this equation. So I'll get 2 over 3x's plus that y is equal to 5. And I got 3x minus 2y still equals 6. And I can go ahead and label these 1 and 2 now because I know I'm going to need that later. This is fine. You could just try to find a number now to match up something. So for example, the y's would be pretty easy to do, but then it's going to be fractional and kind of messy on the top. So why don't we eliminate the fraction first by multiplying the left-hand side by 3 and the right-hand side by 3 in this equation. And come down here. I'm going to write 1 again so I don't forget what I've done. And I've got 2x plus 3y equals 15. If you're confused why that worked out, 3 times 2 over 3 is just 2. And 3 times y is 3y. And so we go to equation 2 now. We've got 3x minus 2y equals 6. And now this looks a lot like that other one. So I'm just going to match up. Let's match up the y values. It's completely your choice. And multiply this by 2. And multiply this by 3. I get 4x plus 6y is equal to 30. And on this one, I'm going to get 9x minus 6y is equal to 18. Now I'm going to subtract or add. Well, the only thing that will eliminate the variable here is if we add. If we subtracted, it would have been 6 minus 6, which is the same as 6 plus 6, which would have given us 12. And that's not what we want. We want them to be eliminated. We want 0. So 6 plus minus 6 is nothing. So I'm going to end up with 13 x's here is equal to 48. Okay, now divide both sides by 13. And you're going to end up with x is equal to 48 over 13. Now we can go ahead and sub that back into one of the equations. Now the nice thing about this first equation being so messy at the start is that it's already solved for y. So let's use equation 1. So we're going to sub x equals 48 over 13 into equation 1. So equation 1 will give us y is equal to negative 2 over 3 times 48 over 13 plus 5. Okay, and how well you can do with this depends on your fractional skills. I'm going to just simplify a little bit here, or reduce a little bit. So 3 goes into 4 once, with 1 left over. 3 goes into 18 6 times, so that's 16. So I'm going to get 2 times 16, which is minus 32, over 13, plus 5. Now I'm going to try to get a common denominator here. So minus 32 plus, this is 65 over 13. So now all I have to do is 65 minus 32, which is going to be 33 over 13. So the point of intersection is going to equal 48 over 13 and 33 over 13. Okay, if you have any further problems with solving systems, make sure you come and see me in class.